This is number 1 on paper 3. It gives us a function in a specific domain, and it asks us to find the second derivative. Okay, so I'm just going to start by writing down the original function. If for any reason you forgot how to take the derivative of a natural log, remember it is on your formula sheet. So the derivative of natural log of x is 1 over x, but remember if the denominator, if this, which you're taking the natural log of, is anything other than x, you have to use chain rule and say times the derivative of that. Okay, so times the derivative of that denominator. Okay, so for us, f prime of x, we would say 1 over all of this times the chain rule times the derivative of the denominator. So the derivative of 1 plus sine x is just cosine x. Okay, so we can just write that as cosine x over 1 plus sine x. Now for the second derivative, we need to use the quotient rule. Okay, so we're going to go low, d high, so the derivative of cosine is negative sine, minus high, d low, the derivative of 1 plus sine x is just cosine x, over low squared. Okay, now it'd be nice if we were done, but it did tell us that we needed to make it look like that. It definitely does not look like negative 1 over 1 plus sine x. So we need to do some simplification. I'm going to go ahead and distribute this. So this would be negative sine x minus sine squared x minus cosine squared x over 1 plus sine x squared. Okay, now hopefully this kind of looks like sine squared plus cosine squared to you, which we know is 1. I just need to factor out a negative 1. So this would be negative sine x minus 1 sine squared x plus cosine squared x over 1 plus sine x quantity squared. Okay, so this part just goes to 1. 1 times 1 is just 1. So in the numerator, I've got negative sine x minus 1 over 1 plus sine x squared. So what I'm going to do is factor negative 1 out of these two things. Okay, so you'd have negative 1 sine x plus 1 over 1 plus sine x quantity squared. And then 1 of your 1 plus sine x's will cancel. So this will cancel, and this will go down to just 1. So you get negative 1 over 1 plus sine x, which is what they wanted us to get. So we have completed part A, and we are moving on to B. Okay, so for BI, it says find the Maclaurin series for f of x up to and including the term in x to the fourth. Okay, so we're going for Maclaurin. I'm just going to make a note to myself, Maclaurin up to x to the fourth. Okay, and I can go to my formula sheet and go to the option page, and it has your formula for Maclaurin. Okay, right there. So I'm going to write that down. F of x equals f of 0 plus x times f prime of 0 plus x squared over 2 factorial f double prime of 0. And I know I've got to get up to x to the third, so I might as well keep going here. X to the third over 3 factorial f triple prime of 0. Oh, it doesn't fit. B plus x to the fourth over 4 factorial, the fourth derivative evaluated at 0. Okay, so I could go ahead and start substituting in now. I do know the first and the second derivative, but I might as well find my third and my fourth derivatives and then substitute in 0 into all of them. Okay, so I think I'm just going to continue on the back here. Let them know I'm still on number 10, and my f double prime of x was this. Okay. Now you have some options. You could bring that to the numerator. I'm just going to use quotient rule. So I'm going to go low. D high would just be 0 minus high. d low, the derivative of the denominator is just cosine x, over low squared. Okay, so 0, I don't have to worry about any of that. Minus a minus, go ahead and make that cosine x over 1 plus sine x quantity squared. And that's my f triple prime of x. Okay, I'm going to go ahead and one more time find the fourth derivative. Okay, I'm going to use the quotient rule again. So low, d high, minus high, d low. Now here you're using the chain rule, so you have something squared, so you're going to move the 2 to the front. 1 plus sine x to the 1 times the derivative inside, which is just cosine x. Over low squared, so squared squared would become the fourth. So next we need to evaluate all of these at 0. So I went ahead and wrote out what we had for f of x, f prime of x, f double prime of x, f triple prime of x, and I didn't want to write all that out again, so I didn't. But just we want to evaluate all of these at 0. So it's kind of easier to do if you can see right beside what you're doing there. So this would be ln of 1 plus the sine of 0. Sine of 0 is just 0. So this is ln of 1, which is just 0. Okay. And then we want to know what f prime of 0 is. So this would be cosine of 0 over 1 plus sine of 0. So that would just be 1 over 1, since sine of 0 is 0. So this guy is just 1. F double prime of 0, negative 1 over 1 plus sine of 0. So that's just negative 1. F triple prime, you have cosine of 0 over 1 plus sine of 0 squared. So that's just going to be 1 over 1 or just 1. And then you're substituting into all of this, 0. So you would have, and I'm just going to kind of do some of this in my head, 1 plus sine of 0 is 0. So this is just 1 squared or 1. So nice old 1. Negative sine of 0, so that's 0. Minus cosine of 0 is 1 times 2. 1 plus sine of 0 would be 1, and raise it to the 1, still be 1. And then cosine of 0. Over, in the denominator, 1 plus the sine of 0, that's just 0. So 1 to the 4th, which is just 1. Okay, so all of this comes out to be negative 2. And now we've got everything we need just to substitute that in and get our Maclaurin answer. So substituting all those values in, f of 0 was just 0, so that's gone. F prime of 0 was 1, so this would just be 1x. And then f double prime of 0 was negative 1, so this would become minus 1/2 x squared. And then this guy right here, f triple prime, was 1, so that's 3 factorial is 6, so this is plus 1/6 x cubed. And then our f to the 4th of 0, or sorry, not f to the 4th, f fourth derivative evaluated at 0 is negative 2. Remember that's 4 factorial. So 4 times 3 is 12, times 2 is 24. So you'd have negative 2 over 24, so negative 1/12 x to the 4th. Okay, and that is your Maclaurin series up to the 4th power. So BII says, explain briefly why your result shows that f is neither an even function nor an odd function. Okay, well, if you'll remember, if you substitute negative x and you get the same thing you started with, that would mean it was even. And if you substituted in negative x and you got the opposite of what you started with, that would be an odd function. Okay, but in fact, neither one of these is true. You're explaining why it's neither even or odd, and that's because you don't have all even or all odd. Okay, all the even ones, if you plug in negative x, they turn into positive. So if you had all even polynomials, every single term was even, it would come out to be an even function. And if all of these were raised to odd powers, when you put in negative x, you'd get the opposite of what you started with, and it would be an odd function. But because you have a mixture, that's the reason why it's neither odd nor even. Okay, so this is, if this is true, it's even. If this is true, then it's odd. Okay, but f of negative x is not equal to f of x, and it's not equal to negative f of x, because the polynomial contains both even and odd powers of x. Okay, the next one, C, says determine the value of the limit as x approaches 0 of ln of 1 plus sine x minus x over x squared. Now, it does not say hence or otherwise or any of that. You can choose any method you want. The reason they connect it with this problem is because you just found a power series polynomial approximation for ln of 1 plus sine x. Okay, that's what you did. Because you did that, that is one way to solve this problem. You could put in the approximation you got. In place of this ln of 1 plus sine x. Okay, now you need to indicate this is dot, dot, dot. The power series really goes on infinitely. Minus x over x squared. Okay, well, what would happen? This guy would cancel, and then if you look, this is as you approach 0. So these terms would go negative 1/2 x squared over x squared plus 1/6 x cubed over x squared minus 1/12 x to the 4th over x squared dot, dot, dot. Okay, and so the limit as x approaches 0 of this guy is negative 1/2. This would be, if you substitute in 0, okay, this would reduce, let's just go ahead and say this is plus 1/6 x minus 1/12 x squared, dot, dot, dot. So when you take the limit as x approaches 0 of this, you would just get negative 1/2 because you put in 0 for everything else. Okay, the other method to solve this is L'Hopital's. Okay, so same problem. What you would do is you would substitute in 0, and if you did, you'd have ln of 1, which is 0, minus 0 over 0. So 0 over 0. Good time for L'Hopital's. This is equal to, I'm going to keep that coming down. Take the derivative of the top and the derivative of the bottom separately. So the derivative of ln of 1 plus sine x is cosine x over 1 plus sine x minus 1 over 2x. So if you substitute in 0, cosine of 0 is 1 over 1 minus 1. So what do you know? 0 over 0. Take the derivative again. Okay, and we already did this. When we took the derivative of this, the second derivative, we got negative 1 over 1 plus sine x. Derivative that 0 over 2. Substitute in 0, you'd get negative 1 over 1 over 2, which is also negative 1/2. I certainly do not want you to work it both ways. You don't have time. Pick one way or the other, and that is the end of problem 1.